So now you can see this model has been run in, and we have our results. Okay, now we go back to map view and we can compare these two ones. So for that it's better to zoom out a bit and compare these ones. So I will, now you can see previously we had a lot of these data which were the values are different, and this is more optimal. And now we have to calculate the volume of the surface. But one point which is important to know is that why we have to calculate surface volume for all. Isn't it that we should be estimating the volume, groundwater volume, or what is the level of depth here for this one on the basis of this data, which is the depth. So what we are going to do is we are going to clip or mask out the area outside the Colli-Embley. So now we have another input. Okay, so that is basically we need to extract. So we will be in analysis tools, extract by mask tool. So here let's drop it first here, and again in ModelBuilder and say here, right? And now we have to give input. This is my input raster, and I have to have another input which is the CIA mask. So this time I will not be dropping CIA mask again because we have already this one, so I can link this data here, simply give it as an input point feature. Let's see what it is doing. And this one is extracting this raster on the basis of this feature mask data. Click OK, and let's do an auto layout to make it nice and tidy. So for the recording you can make it bigger so you can see properly, and we can change the names of the outputs as well. So I will ask it to add to display as well. Now let's run the model again and see what is happening. Validate it and then run. Okay, and now it is at process number 3, IDW. After performing the interpolation, it is now extracting the mask and will give us an output raster only for the CIA mask area. Okay, now it has turned shallow again, so we have done what we wanted to. So now you can see that this is not required, and those areas which were outside, they have been masked out, right? And now we can calculate the surface volume. Okay, so we need to calculate the surface volume. So we have another analysis tool. Let's go to the tools click on the surface. We have to use this one in the model. So not the surface slope, surface volume. Okay, and again I can see auto layout. Let's put it here, and this time we have to calculate the volume here. So this is our input surface and this is our output text file. So where it is storing, it is important to know. Let's give it a name and save it. We can save anywhere inside the database or outside the database. So give it a name, volume _2. So for this practical 2 demonstration I'm using. So we need to see what is the error. The name contains invalid characteristics, maybe. Okay. Now we have this volume _2.txt. Let's auto layout. Now what we will be running, we will be having our output as a text file as well. And now what I can do is this time it has asked added delete intermediate data. This is fine because each time it will be deleting what was the output in the previous run. Okay, and let's validate this one and run it again. So now it is at this stage, which is the interpolation stage. So now you can see that this model is working for itself. Now it is extracting. Now it has deleted this raster because it will be creating a new one and adding to the display. Okay, now this is our extract feature. Everything is updated, complete. Okay, so now we have to go here and see that this has been done once again with the same parameters, but the only thing is we have estimated the volume, and we know that where we were storing that one. If you want to recall, just check the name, or you can copy the path, whole path, Control A, Control C, and click OK or close if you haven't done any change. Okay, now what we have to do is Control V, and this will open. Now you can see that we have this volume here. And one more thing is we have to set the reference plane. So it is calculating the above the plane, but we are dealing with groundwater, so it should be below the plane. And the rest of the things can be blank, or you can put plane height 0 as per instructions. Okay, now you can run this again, right? And for that, run it one more time, because volume should be underground. Volume of groundwater. So this one is in the IDW stage, extract by mask. Okay, everything is complete. We can again go and click, and this time our new run is added. Now we have true model output which is there. The second, now the other thing was what we have to do is we need to search the further optimal distances, because if you see, if I uncheck this one and uncheck this one, or I can put this one down, right? Now you can see this data has been interpolated. This grayscale raster, which is the basically tool to calculate the water volume of groundwater, and it has actually depth of groundwater, right? This raster shows us the depth of groundwater relative depth relative to the surface, and we have to say, okay, it is 0, so you need to change that one in also when you perform surface volume tool. Okay, and it has used these points which are highlighted, or these are selected. And now you can see here we have very few points of observation. So it means that we have to omit those ones. And before that, as a modeler, as a geospatial modeler, because CIA is looking for hiding the surfaces of your surfaces, your services, so you have to show your potential. So why to run this model again and again and see what is happening? So we can add a functionality of automation, or kind of a semi-automation. Complete automation we will do when we will be through with the Python. So I again click this one. So here we have an option. So if I click right, and I can create a variable from parameter and from search distance, on the basis of search distance, because last time you searched the distance and we said that give me okay, where we have 120 meter. Now I, as a consultant, you would like to run the other options, maybe 100, maybe 140, as has been asked in the instructions. So what we will do is we will create another variable on the basis of search distance, and this time we will rename, you can rename this one and call it buffer, right? And it is, now it has seen that it was 120, now 120 is there automatically. And if I change this into 100, it will be updated here. So let's make it to run in a semi-automated way. We can say it is a parameter, and a little p is here. Now I will again validate, right? And I can run my model by giving different options. So now even I don't need to run it again from here. I can close this one, save model, and I can double click here. So I have a little tool now here, and where I can do some playing. Let's do 100. We will reduce the distance and see if we can capture some more points, right? So we will say okay, run. This time it is running outside the model, and even by using this Python we can have our own separate automated tool which we will be doing within this course. Okay, and let's wait a bit to run this model. Okay, it is there. So now let's see. And the third one has been added, and we have a little change in the volume. So if I go to the map view, oh, I'm already there, so I will just open this one. So instead of 46, now we have 61, right? So another thing is, still we are not able to get a good amount of data from these ones, because we have included that from, instead of 120, this time we have run this model for 100 meter distance. So instead of decreasing the distance, we can modify this model, which is the last part of exercise 2, and we, in our CIA WordNet, we have different type of information, and we can actually, if I right click, go to symbology. Currently I'm looking at the data representing this one with single value. Let's do it for unique value, and we have seen channel types. So now it has different options, so I will choose this one so that these are more clear. Now you can see we have different layers. So the bluish ones, they are red ones, they are supply, the purplish are escape, and greenish are, these are drainage. So you can see that we have lot of drainage lines. Drainage are those areas which basically what they do is they take the water when we have flooding. So what we can do is we can remove those basically from our model, so that it will not hamper the data, which is basically what we are doing here is we removed those piezometers which were in closer vicinity, and now we will remove only those channels to incorporate more data which are basically they are not needed, such as escape and supply, because these are having water all the time. But drainage, it has we have water whenever there is a flooding, or when very heavy rainfall is there. So then it will be impacting our piezometers relative depth of water. Okay, that is why now you can see that we are removing that point. This is very important to know. If you have any still some you feel any difficulty in understanding, please do let me know in the discussion forum. But I hope we have here now we are clear. So if I open the attribute table from the selected, and now you can see that we can click here to see all the selected ones. Now if I see these points which are 61 after running the 101, I can open these will also be selected. And sorry, this is CIA mask. What I was looking for the irrigation. Right, so we have supply, we have drainage, these all have been included. So we have 61 points are selected, and we have removed those. Basically we would have selected 220 within that one. So out of those 220, we have selected 61 which are basically within a distance of these lines. Now what I'm going to do is I am adding a new data with a new model, new tool in this existing model, which is basically, if I say analysis, select. So in the analysis, so okay, and I will select these ones. So instead of selecting all, what we are going to do is we are modifying this model, and first we will select this as an input feature. Let's move it a bit so we are a bit more organized. Now you can see that all rest of the model has been turned gray because it has input, but there is no selecting feature. So selecting feature should be this one, output feature class. So this is my selecting feature. This is fine. Now we can run the model, but there won't be any impact because still we are including supply, we are including drainage, and we are including what we call escape channels. Though escape are very less, where the water is released when it is overflown. Okay, so we will add a new expression, right? And where we say channel type is equal to either supply, right? And next time we have to remove those ones which are in the vicinity of 100-meter distance, which is our current buffer distance, 100 meter of supply and escape. So the expression should be OR because we want to select both. So Boolean operator OR is used for and. So channel type again is equal to supply. This time escape. Now you can click OK, and let's. It should not be. It should be this. Now you can see where we have changed, and let's run this model again and see what is the output. We can run it this time here using run option. I'm just validating it again. So this time it will run. Now it is selecting first. It has selected the data from here. Now it has selected supply and escape channels. Now it is performing select by location, IDW. Now it is performing, and it will select those two, and it has removed those which are in the vicinity of 100 meter within the supply and escape channels. So here you will see that these have been selected and removed. Only thing is we have to make sure that we didn't change selection type, which is removed from current location. So now we will again, you need to close this one to see the output. So this, our last one is this one, 2082. So it's about 2.08 billion cubic kilometer because it is in meter cubes. Okay, now it is complete. So for another run we can validate it later on. Now you can, if we zoom to this level, zoom to this layer, now you can see that we have added more data here. Okay, I can bring my selected these one, or I can keep this one here and I can move it down. And this one as well. Now we can see what we are there. So these, you can see that drainage lines, these were not included. These green ones, they are not included in these areas. So it has only selected escape and supply first and performed an optimal run. Right? If you are still not able to understand what we have done here, please let me know. I will have a separate validate it. And now I want to see the output file. Now you can see that instead of 2.08 volume, now we are having 1.746, and our all the run is complete. Botnet have been selected. Right? So first we selected these two and then it was removed from the invitation. Okay, that is it. Okay, one more thing. We can now close this one, save changes, and I can open it, sorry, the file again. What you can do is now cancel, and we can even delete this one, or either you can remove or you can completely delete so that it is made again, because we have to give this file to or keep this for reference. So I can actually delete these two, XML and text both. Now I'm here, I have closed my model, and I will run this model with different options. So first I will do it for 100 meter, run it, 120 meters, sorry. The next is, let's see when it is executed and complete. It is still running. You can see here. Now our output is here. If I move it a bit up to see my, or we will see it later on. Okay, so first run should be the result of 120, then 100. Run it again. Now you can see that we have this kind of a semi-automated tool. So we are there, we are moving towards automation. We just need to do this Python exercise and then we will be ready to go. So next is 80. I will stop recording after checking the file. Let's complete this run. So ideally we should be having three type of three values in our text file. So you can see this is when we selected the distance from the WordNet by 120. This is 100 and this is 80, right? And then you have to plot this against each other, but not for this the first assessment item. We'll be having a separate session on these ones. So you need to increase your needed to increase your modeling capabilities, and then we can work for writing a project proposal or a tender document. Thank you very much.